In a town of 120,000 potential football fans, the football team draws the following attendees per game at the various prices shown. At a price of 0, that is when the tickets are free, 120,000 fans attend the game, 60,000 males, 60,000 females. At a price of 10, 90,000 fans show up. The allocation is 50,000 men and 40,000 women. At a price of 20, we have 60,000 fans, 40,000 males, 20,000 females. At a price of 30, we have 30,000 fans, 30,000 males, and no females. If the firm can only charge a single price to all patrons, the price of $20 in this particular table at point C, the row that is highlighted shows that the price of $20 will maximize the revenue. 60,000 fans at a price of 20. This yields $1.2 million in revenue, or 1,200 is the number highlighted in the row for the revenue, 1,200,000. So 1.2 million is the revenue the firm would make at this particular price. The price of 20 can be sketched on a graph, and we would have a quantity of 60 on the horizontal axis. The price of 20 would be somewhere around here, the midpoint of this particular demand curve, and that would yield a quantity of 60, the midpoint on the horizontal axis, and the revenue will be the rectangular area price times quantity, so 20 times 60 to yield a revenue of 1,200,000, which is 1.2 million. I want you to take a look at this particular table and consider the idea of different prices being charged for men and women. So continue in row C and continue to charge a price of 20 for women, 20,000 females at a price of 20 yields a revenue of 400,000. Let us consider charging a price of 30 for men. The price of $30 for men will bring in 30,000 male fans. 30,000 at a price of 30 is $900,000. So if the firm can discriminate and charge a price of 30 for men and 20 for women, we see it would make 900,000 for men, 400,000 for women, and that yields a total revenue of 1,300,000 or 1.3 million. We call this price discrimination, charging different prices to different groups. And if this is legal and possible, then the firm should do this and increase the revenue beyond the single price revenue, which was 1.2 million. The firm can actually increase its revenue to 1.3 million by price discriminating. If we took the available data and plotted the demand curve for men as well as the demand curve for women, you will notice column 2 contains the price and column 4 contains the quantity of men. Those columns would yield the demand curve for men. Columns 2 and 5 will then yield the demand curve for women. So those are the data we're going to plot. We're going to plot a point A for men, which is 0 on the price axis and 60 on the quantity axis. And we're going to walk to a price of 30, point D, and show 30,000 men. Notice that at a price of 30, no females will attend the game, so the demand curve for women would end at a price of 30, the highest possible price, with the quantity being 0. Here you see the two demand curves again. The demand curve for women has a maximum price of 30, and at the price of 30, the quantity demanded is 0. Notice the demand curve for men has a maximum price of 60, at which the quantity of men attending the game is 0. The point we just made about price discriminating would put us at a price of 30 for men and at a price of 15 for women. Notice the quantity of women is 30,000. Notice the quantity of men is 30,000. And we can calculate the total revenue. 30 times 30 is 900. The revenue for men is the rectangular area under the price and west of the quantity. And we can also show the revenue from women. The rectangular area price of 15, quantity of 30. 15 times 30. Notice that this is actually going to be a greater revenue than what we showed in our table about because what we are showing here is that when you reach the midpoint of the linear demand curve, you will be maximizing the revenue. This is a point we will come back to. You maximize revenue at the midpoint of the linear demand curve. A price of 15 and a quantity of 30. 15 times 30 is 450. So we're actually going to lower the price for women to 15 and increase the revenue. So we're walking down on the demand curve from a point such as 20 for the price and 20 for the quantity to a price of 15 and a quantity of 30. 20 times 20 is 400. 15 times 30 is 450. So we maximize the revenue from women by lowering the price even further. Notice in this particular case now, the price for men that maximizes revenue is 30. The price that maximizes revenue from women is 15. The difference between the two prices is 15. 30 minus 15 equals 15. The formal analysis from the table, we can derive the linear demand curves based on the information in the table. So you'll notice here I've pulled out the data for men and women. The data for men are contained in the table highlighted. And now I'm highlighting the table to the right of that one. And these are the data for women. The table above those two is the aggregate data. So you'll notice that at a price of 0, I have a quantity of 120. The 120 comprises 60,000 men, 60,000 women. At a price of 10, I have 90,000 fans. At a price of 10, there are 50,000 men and 40,000 women. At a price of 20, there are 60,000 fans. And at the price of 20, 40,000 of those fans are men and 20,000 of those fans are women. Finally, at a price of 30, there are 30,000 fans. And you will notice from the table that all of those fans are men. At a price of 30, the table to the right shows that there are no females attending the game. The key purpose here now is to derive what is the demand curve. And I want you to recall from an earlier experience the equation for a straight line, y equals mx plus b, m being the slope of the equation, and b being the intercept on the y-axis. In economics, we focus on the dependent variable being the quantity that's being demanded, and the independent variable here is price. So my y equals mx plus b can be rewritten as q equals bp plus a, or a plus bp. A is the intercept on the quantity axis, and b is the slope of the demand curve. I'm going to have to do a little more explaining of what is about to be drawn. Your calculus teacher would have told you that if you differentiated the equation q equals a plus bp, where q is a function of p, the differential, or the first derivative, would be dq on dp equals b. What is meant by dq on dp? It is how the quantity changes when the price changes by 1. So let's take a look at the data in the aggregate table, the first table. And we notice when the price is 0, the quantity is 120. When the price is 10, the quantity of fans is 90,000. So when the price changes by $10, the quantity of fans goes down by 30,000. Here is the price change of 10, yielding a quantity change of 30. We can reduce that to a slope of 3, where we ask the question, when the price changes by 1, the quantity will change by negative 3, change by 10, the quantity changes by negative 30. So we would say that the slope of our demand curve is negative 3, the slope being dq on dp, change in quantity and change in price. Given that we know that the slope is going to be negative 3, I'm going to write q equals a minus 3p, because I'm going to put dq on dp in the equation. And strictly speaking, that should be a plus dq on dp, but because it's minus, I went ahead and changed the sign. Be very careful there. The guiding principle is that it's a demand curve, so the coefficient on the p term should be negative. So I have q equals a minus 3p, and now the last thing to do is to calculate the value of a. A is the intercept on the quantity axis. So in order to do that, I would choose any PQ quantity. For example, if I chose a price of 0 and a quantity of 120, I would plug in Q equals 120 on the right-hand side, equals A minus 3 times P, and P is 0. So Q equals 120 minus 3P. So you can see here that the intercept is going to be 120 because as I plug in the coordinates 120 and 0, the intercept has to be 120. We can check that by choosing another PQ pair. So let us choose P equals 10 and Q equals 90. And if you plug P equals 10 and Q equals 90 into our equation, we're trying to determine that the intercept is indeed 120. So you plug Q equals 90 on the left-hand side. 90 equals 120 minus 3 times 10. 90 equals 120 minus 30. And that verifies that indeed the intercept is going to be 120. You can check another point to complete the analysis here to convince yourself that this is correct. So let us choose P equals 30, Q equals 30. We're going to put 30 and 30 in for Q and P. 30 equals 120 minus 3 times 30. 30 equals 120 minus 90. And this repeated process has verified that the price and quantity table will give us the intercept of 120 for A and a slope of -3. And therefore we have the equation. From the data in the table, we can come up with an equation for the demand curve, Q equals 120 minus 3P. We can repeat this experiment for the male demand and the female demand, and we will see that the slope is going to be -1 for men. If you were to choose PQ equals 0.60 for men, we would have quantity of 60 is equal to A minus 1 times 0. A would then be 60. Try another pair. P is 10, Q is 50. We have 50 equals A minus 1 times 10. 50 equals 60 minus 10, so A is 60. We're verifying that the slope of the men's demand curve is indeed -1 and the intercept is 60. Let us turn now to the women's demand curve. We can see from the table that the slope is going to be -2. And if we proceed to plug in the coordinates, for example, Q equals 40 and P equals 10 into our demand equation with a slope of -2, 40 equals A minus 2 times 10. 40 equals A minus 20. 40 equals 60 minus 20. So the intercept A for women is also going to be 60. Q equals 60 minus 2P. If you were to take these two demand curves, the demand for men and the demand for women, 60 minus 1P plus 60 minus 2P, you aggregate the 60s, you get 60 plus 60 is 120, minus 1P minus 2P is minus 3P. So when we aggregate the male and the female demand curve, we get what we call the aggregate demand curve, which is highlighted. Q equals 120 minus 3P is our aggregate demand for both men and women. Let us sketch those two demand curves, and here's where it gets to be a little tricky, but this is a convention you should just accept. In Britain, in India, in Japan, in Caribbean countries, and many other countries, they drive on the left-hand side of the street, and when you go there as a visitor, you adapt to it. You drive on the left-hand side of the street. In other countries, they speak other languages, and when you go, hopefully you adapt as well. So this should not be too hard to accept as a different convention. The convention in economics is to put the price on the vertical axis and the quantity on the horizontal axis. You should have met this before in your principles classes. So even though we said the demand curve for men was given by Q equals 60 minus P, notice that when we sketch the graph, we put the price on the vertical axis. So if you wanted a strict comparison between the equation, Q equals 60 minus P, and the graph we're drawing, with P on the vertical axis, given the convention that in your math class you would have said y equals mx plus b, and y would have been on the vertical axis and x on the horizontal axis, then you need to flip the equation around to be P equals 60 minus Q. 60 would be your vertical intercept, P equals 60 minus 1Q. So your slope would have been a rise of 60 against a run of 60. 60 divided by 60, notice the slope is negative, so we have -1 as a slope. So the equation, mathematically, strictly speaking, is P equals 60 minus Q. The demand for women's tickets was 60 minus 2P. If you were to rewrite that equation with P as the subject, you bring the 2P over on the left-hand side, bring the Q over on the right-hand side, so we have 2P equals 60 minus Q. We divide through by 2, so we get P equals 60 over 2, which is 30, minus 1 over 2, which is 1/2 Q. So P equals 30 minus 1/2 Q. Notice the vertical intercept, P equals 30. And notice the slope, a rise of 30. against a run of 60, which is 1/2, again with a negative slope. So 30 minus 1/2 Q. P equals 30 minus 1/2 Q is the alternative way of writing the women's demand curve. Notice that when we write P as the subject, economists call this the inverse of the demand curve, or the inverse demand curve. If you said demand for either one of them, if you were to say demand curve, whether it was P or Q, it would not make a difference, at least in this class. However, the strict terminology is to call the P equation the inverse demand and the Q equation the demand curve. The demand curve differs from the demand function. The demand curve is a two-dimensional relationship of quantity against price, or price against quantity. And the demand function includes all of the other determinants of demand. So it's a bigger system, or bigger equation. Quantity is a function of the price of your product, the price of competitors' products, the income you earn, advertising by the retailers and the wholesalers, and a host of other phenomena. Whereas the demand curve is just the graph you see in front of us. It abstracts from all of the other terms that are included in the demand function. Plotting these 4 points should not be a problem for you. You know that with P on the vertical axis, the horizontal axis will be P equals 0. And with Q on the horizontal axis, the vertical axis would represent Q equals 0. The point A then, P equals 0, Q equals 120, should be graphed on the horizontal axis. We're going to subdivide the distance between 0 on the quantity axis and 120 into equal segments. So I have here 30, 60, 90, 120. Hopefully this looks equispaced, but you get the main point. And on the vertical axis, I'm going up to P equals 40, because the inverse demand curve, from the demand curve Q equals 120 minus 3P, if I were to rewrite the equation, the inverse demand curve would be P equals 40 minus 1/3 Q. 40 would be my intercept. So 40 is the highest point I'm going to identify on the price axis, my vertical intercept. The slope is going to be a rise of 40 against a run of 120. So P equals 40 minus 1/3 Q is my demand, or inverse demand curve, when I sketch the analysis. Again, I hope you get the point that the graph is drawn backwards, so to speak, but that's the convention in economics. I'll say more about that a little later. In the right-hand panel, I show you the revenue as the price times the quantity, the price of 20 and the quantity of 60. The rectangular area, 20 times 60 is 1,200. That represents the revenue that would be obtained if the price of 20 were charged to all patrons. And if I charge a price of 30 to men and a price of 15 to women, you would see the rectangular areas here representing a revenue of 900 from men and 450,000 from women. And we call this price discrimination. Notice the total revenue is 900 plus 450, which is 1,350. These are in thousands, so that's $1.35 million. It's important that you be able to interpret what the slope means. In the equation Q equals 60 minus 1P, the slope is -1, and we interpret that to say that as the price increases by $1, the quantity decreases by 1,000. And on the right-hand side, Q equals 60 minus 2P. As the price increases by $1, the quantity declines by 2,000 women, so that when you aggregate the two analyses, if the price were to increase by $1 for both men and women, the quantity of fans would go down by 3,000. 2,000 fewer women, 1,000 fewer men.